the mean, the standard deviation. She said you could just describe the shape, or anyway, whatever applies to our
well, if you did a
test.
histogram, or you could do pie chart, or you could do a bar chart.
Here's another group. They did 3 different sizes bags. They did a 14-ounce bag, a small, medium, and a large bag.
But then you're going to have to rewrite your whole thing.
Yeah.
We're better off just getting extra bags and making our sample size bigger than rewriting everything and then trying to figure out a whole new question.
Well, yeah, sure. I'm just saying that there's other people who have done a little bit different, similar.
Yeah. Yeah. All right. All right. Well, let's get on with this lesson. This is group 7.
And they did the chi-square too.
Did they?
But again, their question was, are they or are they not, kind of thing. Are they evenly or not? So.
Huh. Interesting. All right.
What do you know? There's actually like 4 or 5. Sorry, go ahead.
You're fine. You're fine. You're fine. All right. This is lesson 22. So let's just go over part 2 real fast. It says, answer the following questions, use the gharial crocodiles data.
Did you guys watch that video?
Yeah.
I'd like to have a crocodile that big coming at you.
Yeah, no kidding. That would be crazy. That'd be crazy.
40 feet long.
Yeah. All right. So question number 6 wants us to decide what is the explanatory variable and what is the I guess I have to open it up. What is the dependent variable or response variable? Yeah.
Well, the explanatory is the head length, because that's what you're going to use to predict the body length.
The body length, yeah. So number 7 is body length.
And number 6 is head length.
Yeah. Yeah, anything you predict, or the one way they described it in the video is if the change of, let's see, if one can, how did he word it? It actually helped explain it better.
The explanatory is using to predict. The response is the one that you're trying to predict. And
yeah. Well, and he said if they don't line it out, tell by is the one affected by what happens to the other variable. So, for example, if they're testing, they want to see if height and weight correspond. Well, if can height be affected by weight? No, not really, but can weight be affected by height? So weight would be the explanatory variable, the one that they're trying to predict, or no, excuse me, the response variable.
Response
variable. Then the other one is the independent, or
the independent is the one that's not going to be changed. It's not going to affect it. The y's, the reason they write that y equals to b ought plus b1. Or it's so that you don't have to change the y. You can now just add whatever you want on the other side of the equation.
Exactly. Okay, and then it wants us to create a scatter plot representing the relationship. So do you guys have your SBS all up? Do you want me to share my screen? Whatever works.
I have it up too.
Okay. So how we would do that is you go to graphs, legacy dialogues, down to scatter and dot. And then we decided that head length was x-axis and the body length was the y-axis. And then we hit OK. And then they wanted, they just wanted a scatter plot for that one.
Yeah, they didn't want a line through it.
Yeah, not yet. And then it said use the software to compute the value of the y-intercept in the regression line. So that's where you go to analyze, regression,
Linear.
and our body length is the dependent factor, and head length is the independent factor. And then you can hit OK. And that gives us under understanding coefficients under B. That's the y-intercept. It's, what do you have, Chris?
Negative 69.369.
Okay. And then the slope. Eduardo or Carrie, do you guys have that, or?
I actually didn't get this done, so
Oh.
I totally trust you guys.
All right. The slope.
7.4.
Yeah, 7.4. And then they want us to write the equation for the regression line. So it's y hat equals negative 69.369 plus 7.4 times x.
Yeah.
And then they wanted us to go up to that scatter plot and draw the regression line. Right? Yeah.
Yeah.
So you double click on the graph. Maybe. It doesn't want to. Oh, there
And
it
then you
is.
start elements.
Yeah.
And then it'll say fit line to plot. Or something
Yeah.
like that.
Total. Yeah. And then it's just, they throw a line through it. Okay. And then they said for the observed head length of 51 centimeters, what's the observed body length? And you can look at the data file. If you just click on the gharial crocodile, go find 51 in there. It's like number 8. It said the body length is 343 centimeters. And
Okay,
then,
now when I did it where you added the 51 at the bottom,
yeah,
I got a different answer.
yeah, you do. So you can do it. That's a more accurate way. And that's what they're going to ask us in 15. So if you type 51 at the bottom and go back up, hit analyze, regression, linear, save.
That was the hardest part for me, was I was trying to save it on the other side, and I'm thinking, well, this isn't working. It's not giving me that check box that I can put in.
Yeah.
I was trying to save it to the desktop or something, and I'm going, no, wait a minute. So I had to go back and watch the video to see where he got the save.
Why is he saving that? Yeah, exactly. Well, and so it does. It gives you 3.08.03297. And what they said is if you go look at the line, let's see, where's my box? If you go up and look at the line and look for 51, he said it's the point that's closest to 51 actually isn't right on the line at 343. It's actually closer to 308. So
well, that's because
said the points are
it's not an actual, they're not right on the line. They're above the line, below the
right.
line. We're just looking for the line. We're just looking to see what kind of shape it is. Is it linear in shape?
Yeah. And it's just a prediction, so it's not an accurate, yeah. So, all right, that's it. So we can start the quiz.
The quiz is kind of the same thing, I think. I looked at it.
Yeah, it looks
You have
looks
to
like
open the whatever it is, math efficacy one.
Oh yeah.
Aren't there
Yeah,
the same files be open on Tuesday?
Yeah.
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 Because you can actually run both of the tests. We were like in the homework. It actually has you for one of the problems doing the
both?
bivariate. Yeah, yeah.
Yeah.
So. on. Sorry, mine's opening up. And always, does anybody else's take forever to open
Yes, and I always worry. Well, then I got that crazy
up? Error thing. Yeah. Programming box where
I'm like, that's the last thing I needed is the cancel right before the final.
It's no fun, believe me. You stress a lot when you lose your computer and you're in an online class. You go,
Absolutely.
I'm sorry, Sister Cook. Our group is going to have to do the final together.
Well, like, so sorry. We'll be driving to each other. Well, I had one year. It wasn't a final, but I had something, and he's like, "Well, don't you think you should have planned better?" And I go, "We had severe weather. I was out without power." And he's like, "Oh, sorry." Like he kind of backed up because he's like, "Don't you think you should have planned?" He literally told me you should have planned better, and I said, "Well,
Oh, gee.
you're right. I shouldn't have waited until the last day, but I have every right to wait up to the last. If I want to."
Right.
But
and we live in Texas, and if it's spring, we're gonna get crazy weather.
But I was like, I have no control of the weather, and he did back off. He reopened it, but I thought that was a little rude.
I know. Yeah. Sometimes they can be intense. All right, question 3. It says, given the linear regression equation y equals 2.0 plus 1.5 times x, what is the y-intercept round to 1 decimal?
1.5.
I would say 2.0. I think 1.5
it's
is our slope.
2.0. 1.5 is the slope. Yeah, you're right.
Oh,
Okay.
Hold on. Might be why you decided that I have been out too long, and
it doesn't like you. It's all good.
I have to say, the closer I get to that finish line, the harder it is to stay on task.
I'm sure. I'm sure you're just ready.
Okay. Sorry, I'm holding up.
You're fine.
So we're in lesson 22, right?
Mm-hmm.
Uh-huh.
Okay, sorry.
You're fine. I'm trying to find my pen. Where's my pen? All right, that's it.
Mine are usually stuck in my pocket. It's an old nurse's.
Yeah.
That is a nurse thing.
Goes in your pocket.
That's a smart place to put it.
All right, so we're at question 3. The y equals 2.0 plus 1.5x.
Right.
Okay.
Yeah, we're on question. We just did question 3.
Okay, what was the answer?
2.0.
2.0.
Yeah. What's the y-intercept?
This is like algebra.
It is.
Yeah. Yeah. I know.
Except
It's
they
more
renamed
predictable. Except what?
They renamed it.
Another.
Right.
Yeah, they can't leave it y equals mx plus b or whatever it is.
Y equals mc squared.
No, y equals mx plus b. That's the slope and the y-intercept. But
oh yeah, that's right.
in algebra, but now it's y equals b op plus b1 times x. I mean, it's like, really?
Yeah.
They couldn't leave it alone?
Right. Right. Okay. So 4.
We got
we already
1.5.
1.5. Yeah, that's our slope.
Number 5, I got 1.0.
I got that as well. So you just plug in
1.0?
Yeah. So you plug in 16 and x, times that by 25, which gives you 4. Add that to -3, which gives 1.0.
Okay.
All right. Okay.
Is it a hot dog, a hamburger, or a banana?
Or is this the one on the math?
Right. Yeah, we go to the math one, confidence data for the x, and score data for the y. I was just reading that. Okay. Sorry. All right. So we want to graph it, I take it first.
Right.
Okay, scatter dots. Define confidence data for.
Confidence is on the Y.
Say that again.
What's on the Y-axis? The confidence rating?
The score is in the confidence. It said that was the response variable. Good night, bud. Love you. And that the confidence rating mean was the X. Yeah.
Oh, it looks like a hot dog.
You said hot dog?
That looks like
Well,
something
It
else.
looks like one. But if you
Yeah,
try to close
well-
your eyes, it looks like a big old hot dog. It's not round. And it
Yeah.
doesn't have a curve on the bottom.
Yeah. It's linear. It's just not a strong linear. It's more of a
Right.
moderate to a weak. Well, not quite weak, but
It
it's,
was like a hot dog transitioning into a banana to me. But...
Yeah, but we haven't got to the banana
That's right.
yet.
Oh, well, see?
Yeah,
That's exactly how you know it's not a banana, because we haven't gotten there yet.
That's right. It may get there, but right now it's not a banana.
Okay, so based on the shape of the scatter plot you produced in the last question, what can you say? Well, like Stacey was just saying, simple linear regression is appropriate for these data. If simple linear regression is used for these data, the results will not be reliable. Simple linear regression is not appropriate for these data. Which one?
You can use it's appropriate
yeah, I agree. I think it's
So-
appropriate.
Me too.
Simple.
because it's not a banana yet. If it were a
Right.
banana or a hamburger, we couldn't use
Not a
simple.
banana yet.
So how many observations are in the data?
Oh, that's on the number. That'll be on the number. Just hang on. I have-
Would you just pull the highest number on the scatter plot?
No,
Well-
it'll show you in a number. I think when you do the data, I think it'll do it. Won't it?
Yeah. Let's see. So analyze regression. Linear. Let's
Now, which is
see.
you said the score?
Yeah. That's
And
the
the
one that's
Okay.
yeah. Okay. All right, what if we do, let's do the bivariate. Sorry. Okay, I have 139 when I did the bivariate. Gave me a sample size of 139. And that's actually, if you just scroll down to the bottom of the numbers and the data file, it's 139 as well. That's kind of an odd question. I've never had them say.
Never asked that one.
I mean, if they'd say it was sample size, but that's kind of tricky. How many observations are in this data? Well, are you talking about? Anyway, like I'm saying, could it be double that, like 178? I mean, 278.
Wouldn't it be our total?
Yeah.
You're right. It is a little tricky. So is it sample size, or because is it considered a different observation if it like doubles up the same number?
Right, because are we doing is score and confidence rating each their own observation? But I guess we can put one and see what it says, and then go back if we need to. But
Because the sample size is 139, isn't it?
I think that
Yeah.
they're gonna. I would just leave it at 139, but then we may be wrong.
yeah,
I think that
That's
makes
what
more
I'd say
sense.
is-
Denny.
yeah. Then it wants to know what the y-intercept is. That would be. I've got 18.690.
Yep. That's what I've got.
Okay.
And the intercept
Then-
is 12.695.
The
Right?
slope.
Yeah, I mean the slope. Yeah.
Yeah, 12 point, yeah, 695.
Wait, what was the
Huh.
y-intercept?
Again, Eduardo?
What was the y-intercept? Sorry.
It was 18.690.
90. Okay, thank you.
Uh-huh. Okay. Ah, what is that? Okay. All right, sorry. What is the predicted value of y when x is 4? So that's when you can go to the data, type a 4 in the
4 at the bottom.
confidence. Analyze regression. Okay. Okay, let's see. I've got 69.469. But let's wonder if we can, let's see. Let me
You said
try.
you got 60, I got 69.47.
I got 469 because they want us to
To
keep
go to
it.
3.
Oh yeah. You're right.
So question 11 is 469.
Yeah.
It's
Even?
69.469. Yeah.
I'm sorry, what?
69.469.
0.469.
0.469.
Yeah.
Okay.
But it's okay. But it's
Yeah.
69.469.
Yeah, if you did it by hand, it gives you 69.47. But if you did it through the software, it gives you the 0.469.
Well, since he wants it to 3, I would go with the 69.469.
Yeah.
So it's 69.469.
Yeah. The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for the values of x?
Use the largest
can-
X to find the largest Y.
Okay, so it looks like we go into this. Okay. There's 5, 7. Let's see if there's a 6 in there. If not, we have to find all the 5. Wait, there's like 130. Okay, there's a 6 in there. So we use 6, right? Because 6 is our largest possibility. Yeah. Okay. So I'm going to type 6.
So you're gonna put 6 at the bottom?
Yeah, and then just do that thing again. And it will type up a second column, pre-2, and it says 94.859.
It's 95.849?
94.859.
I just mixed them up. Okay.
94.859. I had to look myself, like, did I say that right? Okay. All right. How many explanatory independent variables are present in a simple linear regression? How many
There's one.
You
Because
said
if
one?
he uses more than one, he said in there if you need to evaluate more than one independent, you need to get a statistics professor. Because he wasn't going to close that. Isn't that what he said?
Yeah. I think you're right.
It seems like he said if you were going to evaluate more than one, that's all we were going to evaluate was just one in a simple linear. And if you had to evaluate more than one, get a statistics professor or
someone
go
at
on to take
a
another
higher pay grade.
Yeah. Response variables are present in a simple linear regression. Response, that's a y. These are kind of tricky questions.
I don't like these.
I know. I'm thinking What are you talking about?
Oh, you know what? No. That's why the y is set all by itself, because you could add as many x's as you wanted. So maybe there's, I don't know.
I know. Was this in the reading? I'm trying to remember, honestly.
Well, I just remember him saying that if we, I just thought I remember him reading that if you wanted more than one, and let me go back and see. Hmm.
Let's see, I'm going to go also. It's one of those tricky questions where it's like, guess what I'm thinking and pay attention to exactly what I'm thinking. I know the answer's there. I just didn't pull it out. Let's see. Okay.
But the way he's got the question worded, it says, because if you have a y, the y is there, but you could have, because he says in there you could have like a b of 1 and a b of 2 and a b of 3 and a b of 4, but the answers that he gives, that he lets us have, is either there's 1, 2, or more than 2.
Yeah.
And usually there's just 1. You could go more than 2, but typically there's only going to be 1. Because we're not going to get into that.
I know.
It says a simple linear regression. I'm still thinking it's going to be 1.
Okay, so which one? Let's see, multiple regression. Sometimes it's necessary to use more than one predictor independent variable to predict the value of a response dependent. So it says sometimes it's necessary to use more than one
But
x.
keep going. Doesn't he say, though, that if you're going to need to use more than 1?
Yeah, let's see, variable to predict the value of a response, y. For example, if we want to predict the stopping distance for a car on dry roads, we might want to use the initial speed, the weight of the car, and the amount on the tread. Although it's fairly straightforward to create a model to get the estimated multiple regression equation, the interpretation of the results can be a little tricky. If you need to conduct multiple, you may want to study the topic in depth. But it says you can have more than one x for a
single
one y. Yeah. So I would say, let me go back to the question.
More than 2.
So for
but you don't have to use more than 2. And it says it's a simple linear regression.
So you could think of it as it going. What's the minimum you need for it to be considered a simple linear regression? Then it would be 1.
Be 1. Because you wouldn't always have more than 2. Sometimes you would have 1.
But you would at the very least have to have 1.
Yeah.
Right? I'm cool with 1. We have 2 tries.
For which one?
So let's just say one on 13.
I agree with you guys that it's sometimes the wording is.
What about for 14? Is it more than 2? Do you agree on
No,
more?
14 is
I would
only
just say
one.
1. Yeah, 14 is
One,
1.
because that's the one you're
So
trying to.
1 and 1 for 13 and 14? Both 1?
Yeah. We'll see how it goes.
All right.
And then in 15, it says a company in South Dakota manufactures hard hats using the mining industry. They record measurements on all hats they produce for quality control and planning purposes. Measurements they collect include hat size, circumference of the hat, the lengths of the major and minor axes, meaning the company wants to predict size of hat given the circumstance. What is the response variable?
The circumference.
Circumference.
Well, so the response variable, isn't that the y? And if so, it's what we want to predict. Let's see. I'm just looking at my notes. Yeah, so y is the response variable.
Is the predicting, and the explanatory one that's using to predict.
Okay, so they want to predict the size of hat given circumstance. So I would say that the size of hat is our response variable. It's our dependent.
Because it's the variable being predicted.
Yeah.
And the circumference is the using to predict. So it's the explanatory variable.
So
Yeah.
it's the third one down. The size of the hat is
It's the first one.
First one. Okay, so I'm going to submit. Let's see what happened.
So you agree with the first one?
What was that?
Be the size of the hat, right? Because it's the variable being predicted.
Yeah.
Okay, good.
because the actual measurements, their circumference.
Right.
Yeah. Okay,
Once
we
again,
got 100%.
double negative.
You what?
A double negative.
That's
So
right.
it is one on both of those then.
Yeah, we got
I think
100%.
I think the way it's written is like kind of like what's the minimum, I guess.
Yeah, well,
You have more than one, but you could have like 5, you know. But you got to
maybe-
have at least one.
but maybe, oh, okay, you know what? All right, there was something I wrote in my notes that probably I just forgot and didn't even think about, but it talked about, what it said was, sorry, I'm trying to find it. It said if it talks about,
They would always say multiple if it, but otherwise
Yeah.
it's just going to be a simple. And
yeah,
it's
it
just gonna be
says unless the
Yes.
word multiple is used, always assume that you're dealing with simple linear regressions. So then you just have one on one. Well, then they'll use the multiple name. So, whew, that was a hard one. Okay,
Good.
sweet. So, okay, so how do you guys want to proceed with describe the data? Do we just want to wait? Let me go look at my email to see if she responded yet. Sometimes she responds around this time. Sometimes it's not till a day later. Come on. Come on, come on. My BYU is kicking me out too. Let's see.
They kicked you out? Uh-oh.
Well, no, that's right. I'm in trouble. No, it just logged me out. I'm just saying, let me in. Okay.
That's because you can't open 2 things at once in there.
Yeah. Oh, great. Okay. Let me.
I missed one. It's 88.
But if she hasn't responded, do you guys want to try and get together?
I'm down, yeah.
I think my husband's trying to plan a date for tomorrow night. And so
Well, you have a
I
curfew.
know.
You have a curfew too.
I know. We might go watch the BYU men's volleyball play. Okay, yeah, it doesn't look like she's responded. So
I really could. We wouldn't have to work very long, so
Yeah.
no.
I wouldn't mind getting on late. It doesn't matter to me. But I don't want to.
Okay,
speak for Chris.
What's the earliest you guys can meet, and what's the latest you want to try?
For tomorrow?
On Friday?
Yeah.
The earliest I can meet is at 4:30 our time, so it's 3:30 your time.
Okay.
I'll just match Chris.
Oh,
So
The earliest
You
I
can
can
do
meet
that.
is like around 4:30 because I have class.
So that's 5:30 their time.
No, 4:30 your time. I'm in Idaho.
we're in Texas.
Yeah.
Oh, oops. Yeah.
Yeah. So it's 5:30 Texas time.
So we're behind you. We're ahead of you.
Yeah.
Yeah, you're ahead
Yeah.
1 hour.
Okay, so you want to do the 5:30 then tomorrow night? What does that do to your dinners?
It's called cereal, and it has happened the whole semester.
Oh, okay. Cereal works.
Okay, so we should 5:30.
What time?
We'll plan on 5:30 unless you hear something different.
Sounds good to
5:30
me.
Mountain Time.
So are we gonna go ahead and plan having another bag already counted?
We could, if you
I
guys
mean-
want to, just in case we need it.
Okay.
And
I don't mind I'm gonna have to twist my kids' arms to eat candy. So
Right, that's okay. So
I'll
how
go
about
ahead and if we need it, great. If not, that's okay too.
Okay, everybody buy one more bag, count it out. We'll meet 5:30 Texas time, 4:30 Mountain Standard Time, Idaho time.
5:30 Mountain Standard Time.
Yeah, 4:30? Does that work for you, Eduardo? You said 4:30, right?
Yeah.
Okay, yeah, then that works great for me.
That works.
Okay, and then if I still don't hear from her, I'm hoping she responds, but anyway, then we'll just go ahead, add the sample size, and go with what we have.
Go with what we've got because we get answers for it. We get the means, we get the standard deviations, we get all that information.
We get the F distribution, the P values, everything. So,
Right.
okay, cool.
All right.
Thanks, you guys. You're awesome.
Yep, see ya.
Thank you, everyone.
Bye.
Good night.
Bye.
Good night.